All right. Hey, party people. All right. Section 6, topic 6 is going to be on page 100. So please turn to page 100. This one is going to be a little spicy. I want to go over some stuff before we dive too deep. Because we're going to be taking regular equations and regular quadratic equations and putting them in vertex form. I'll show you what that looks like. So here you have what a regular quadratic formula or a quadratic equation would look like with ax squared plus bx plus c. And then you have vertex form, which you have a, and then the parentheses of x minus h squared plus k. So we're going to break down what that looks like, but basically you're going to turn the top equation into the bottom equation, and a will stay on the outside, and then h and k help you determine where your vertex is, which is super helpful once you get the hang of it. All right, so let's start off with this one, x squared minus 6x plus 8. I think I might have changed this one because it did have decimals, and we're going to use this. Okay, no, I kept this one. Okay. I did change some of the ones in the next couple that did have decimals. So here we have x squared minus 6x plus 8. You'll notice I put a huge gap between the 8 and the negative 6. And that is because in order to turn this into vertex form, the easiest way to do it is just to put what would complete the square. So when you think about that, think about what number adds by itself to become negative 6. And that would be negative 3 and negative 3, which would multiply together to be 9. I know that's a little confusing, but it'll make sense in this next step. So we want to have plus 9 because then this will become a perfect square over here. However, we can't just add 9 out of nowhere. We can't just be like, hey, let's add 9. We need to also subtract 9 because then we're basically adding nothing. So you add 9 over here and you subtract 9 over here. So we've done no harm because plus 9 and minus 9 is the same thing as adding nothing. So really we've just moved this equation around by doing this. So x squared minus 6x plus 9 would become negative or minus 3 minus 3 squared. So and then plus 8 minus 9 would become negative 1. So hopefully you see how I got that. And then you bring them together, and this is what it would look like in vertex form. All right, maybe practicing a couple will make it make more sense. Again, feel free to ask around if you have more questions about it, but we'll do a couple more. Oh, sorry. First, we are going to graph this function. So let's do a couple points. First of all, we know what our vertex is because it would be the opposite of this, like 3 minus 3, so positive 3, and then you're left with negative 1. So your vertex is positive 3, negative 1. So let's plug in some points that would be around that. So 1. If you plugged in 1, 1 minus 3 is negative 2. Negative 2 squared is 4. 4 minus 1 is 3. Let's plug in 2. 2 minus 3, negative 1. Negative 1 squared is positive 1. 1 minus 1, 0. We don't need to plug in 3. I put it on here anyway. You get negative 1. And then plug in 4. 4 minus 3, 1, 1 squared, 1, 1 minus 1, 0. We're repeating ourselves. So 5, 5 minus 3, 2, 2 squared, 4, 4 minus 1, 3. So here's our lovely quadratic mirroring that we have right here with our axis of symmetry of the vertex. Let's go ahead and plug those points on the graph. 1, 3, 2, 0, 3, -1, 4, 0, 5, 3. Feel free to pause if you need a second to put it on your graph, but you should get a lovely graph that looks like this. All right. So let's practice some more. All right, so this one has decimals and is a little complicated. I just want you to get the hang of this, so I went ahead and I changed this. So go ahead and scratch out what was there, and feel free to put this new equation up there. All right, so now we have a couple tricks to us. We have this 2 in the front, so that's going to mess with us just a little bit. But we're not necessarily having to put this in vertex form. We can, but we mostly want to determine key features. As we did in a previous one, we can easily determine what our y-intercept is, because if we plug in 0 for x, all we're left with is 10. So our y-intercept is 10. All right, let's go ahead and put this into vertex form, because then it will be super easy to identify the other key features. And I want to see more practice with that. Okay, here's where it gets a little crazy. I separated them, but we have this 2. This 2 throws some things off. So you're going to want to pull the 2 out of what you're going to make your perfect quadratic equation over here. So 2 out of the 2x, it just leaves you with x squared. 2 from the -8 leaves you with -4. So now we need to determine what makes this a perfect square. And 2 things that add together to be -4 evenly is going to be 2 and 2. So we're left with 4. So here's where this gets tricky. Remember how when we added the 9, we took away 9 on the other side? Here, we're not adding 4. We're adding 8. Hopefully you can see why that is without me even giving it away. But you have this 2 on the outside and then the 4 on the inside. So if you did 2 times 4, remember we pulled this 2 out. This would actually be 8 if we did not pull this 2 out. So since we're adding 8, we're going to subtract 8 on the other side. So this perfect square becomes, and 10 minus 8 is 2. So this perfect square becomes x minus 2 squared with the 2 still on the outside. So our a is still there, and then now plus 2. It's in vertex form. We can do a lot with this. We know our vertex, and then we can solve for zeros, but we have no zeros in this case. And that's because it's a positive, it's going upwards, and our vertex is already positive, so it's not going down towards the zeros, it's going up away from the zeros. So, all right, so again, they gave us a weird one with decimals. So feel free to change it to this new equation right here. Hopefully this will be a lot easier for you to use. And yeah, let's go ahead and dive in. So we're going to do the same thing we did with splitting them up. We have 2x squared minus 12x, and then over here we have 10 by itself. We want to figure out what would complete the square for the first part, but first let's pull out the 2. So if we pull out the 2, we're left with x squared minus 6x. So let's think what would complete that square. If we have minus 6, what are 2 things that evenly add up to 6? And it would be 3. So -3, -3, and those both would multiply to be 9. -3, -3 multiply to be positive 9. But again, we didn't add just 9 because there's a 2 in the front. So really, we pulled the 2 out and we were left with 9. Really, what we did is we added 18. So we need to subtract 18 on the other side. So once we do that, we can complete our square, and we're left with 2 times x minus 3 squared minus 8. Now that we have this, it'll be a lot easier to graph and to make a table out of. So let's go ahead and make our table. So if we plug in, so we have our vertex, which is at 3, negative 8, because again, we have our equation right here, and we know if it's minus 3, it's positive 3, and then we have the minus 8, so negative 8. And then we have our y-intercept is at 10, and I can figure that out from the first equation, because if we plug in 0 for both of them, we get 10. So then let's plug in for some other numbers around the vertex. If we plug in 1 minus 3, negative 2 squared times 2. 4 times 2 is 8. 8 minus 8, we get 0. That's one of our zeros. All right, and then let's plug in 2. 2 minus 3, negative 1. Negative 1 squared is 1. 1 times 2 is 2. 2 minus 8 is negative 6. Negative 6. So 3, we know what we're going to get already. 3 minus 3 is 0. 0 times 2 is 0. 0 minus 8 is negative 8. That's our vertex. And then if we plug in 4, well, we're going to end up getting the same thing we got for 2. Plug in 5, same thing we got for 1. So easy peasy. Now let's just plug those points in. So we have our y-intercept, and then we have 1, 0, 2, negative 6, 3, negative 8, 4, negative 6, 5, 0. And because we know that this was 10, we actually know that 6 would be 10 as well. So we get a nice nice little U. Oop. All right, last question of this section. April rewrote a quadratic function in vertex form. So here we're given our function. And let's see how she broke it down. She took the 5 out at the first part, similar to how we were taking out our 2's, and everything looks good there. And then she added 9 to make this a perfect square. Well, 9 times 5 is 45, so on the other side she should be subtracting 45, which she is. However, it's the next, going from step 2 to step 3, where something seems a little off. So let's talk about that. And she also said that the vertex is 3 and 15. Is April correct? She is not correct. Can you see what she did wrong between step 2 and step 3? It has to do with the 30 and negative 45 and minus 45. 30 minus 45 is equal to negative 15, and she put positive 15. So it would actually be h of x is equal to 5 times x minus 3 squared minus 15, and therefore the vertex would be 3, negative 15. All right, well, I hope you enjoyed this section. Hopefully learning how to turn things into vertex form makes it a little easier for you when you might choose to do that in the future to make it easier for you when solving a quadratic equation. It can be tough when there's decimals involved, but hopefully the way we did it made it a lot easier for you. All right, see you in the next section.